Hi guys, this is Miss Gold. Today's lesson is Module 6, Lesson 7, Real World Volume Problems. Your outcomes for today's lesson are students use the volume formula for a right prism, V equals B times H, to solve volume problems involving rate of flow. Now I want you to notice it says rate, and we did that at the beginning of the year, and I just want to remind you that it was very helpful for us to find unit rates in order to calculate any other type of rate. So we want to look at that in this, any of the examples that we get. You're going to want to turn any rate into a unit rate. So let's take a look at example 1. A swimming pool holds 10,000 cubic feet of water when filled. And I'm just going to highlight as I go along. Let's highlight some important information. John and Ann want to fill the pool with a garden hose. The garden hose can fill a 5-gallon bucket in 30 seconds. If each cubic foot is about 7.5 gallons, find the flow rate of the garden hose in gallons per minute and cubic feet per minute. About how long will it take the pool with a garden hose, how long will it take to fill the pool with a garden hose? If the hose is turned on Monday morning at 8 a.m., approximately when will the pool be filled? So the first place I want to start here is you'll notice we don't have a unit rate here. It says 5-gallon bucket in 30 seconds, and they tell us here that they want that to be in minutes. So the first thing I want to do is I want to turn my rate into a unit rate, and not only in seconds, but I also want to turn that into minutes. So let's start with the original one they gave us. 5 gallons fills in 30 seconds. Now, I know that there are 60 seconds in a minute, so if I want a 60 on the bottom here, I'm going to multiply both the top and bottom by 2. So that's going to give me 5 times 2 gives us 10 gallons in 60 seconds. And this is a unit rate because we don't actually want seconds, we want minutes. So 60 seconds is equivalent to 1 minute. So this answers the first question of find the flow rate of the garden hose in gallons per minute. The next part, though, is that they want us to find it in cubic feet per minute. So let's start with our rate of 10 gallons per 1 minute. And we're going to multiply this by the fact that they tell us that cubic foot, meaning 1 cubic foot, is about 7.5 gallons. So 1 cubic foot is about 7.5 gallons. So you'll notice here my gallons are going to cancel. We multiply across, so 10 times 1 gives us 10. And on the bottom, we have 7.5 minutes. Now again, this rate is not going to help us. We want to turn it into a unit rate. So I'm going to divide these two numbers, and I get 1 and 1/3. If you try that on your calculator, you're going to notice that it is a repeating decimal, and we want it to be exact. So we're not going to take the number and round it. We really are going to turn it back into a fraction or mixed number so that it is an exact answer. All right, so now I know how much is the cubic feet per minute, and I also know the gallons per minute. Now, the reason we want the cubic feet per minute is because you'll notice here, the original amount that they tell us the pool holds is in cubic feet. It's not in gallons. So that was important for us to find this piece of information. So from there, if we know we want to fill a 10,000 cubic foot pool at a rate of 1 1/3 foot per minute, we're going to divide these two. Cubic foot per minute. Okay, so we divide those two and we get 7,500 and that's in minutes. So it's going to take us 7,500 minutes. Now, That doesn't really help us. What we really want to do is we want to turn minutes into hours and see how many hours and minutes it's going to be so we can answer this question. If the hose is turned on Monday morning at 8 a.m., approximately when will the pool be filled? So we've kind of answered the question here about how long will it take the pool to fill with a garden hose. It's going to take 7,500 minutes. Why don't we turn this into hours? So we're going to divide this by 60 minutes. That's going to cancel our minutes and give us 125 hours, which we know that there are 24 hours in a day, so this actually works out to be 5 days and 5 hours. Okay, so let's answer our final question here. If the hose is turned on Monday morning at 8 a.m., so we'd start Monday at 8 a.m., when you add 5 days and 5 hours to that, okay, so if we count through 5 days, Monday to Tuesday, Wednesday, Thursday, Friday, Saturday, so it's going to be Saturday. And 8 a.m. needs to add 5 hours to it, so 8 to 9, 10, 11, 12, 1. So it will be Saturday at 1 p.m. is when the pool will be done filling. So you can see these problems are quite complex, and a lot of this actually has to do more with unit rate than with volume. Let's take a look at example 2. A square pipe, meaning a rectangular prism-shaped pipe, with inside dimensions of 2 inches by 2 inches, has water flowing through it at the speed of 3 feet per second. The water flowing into a pool at the shape of a right triangular prism with a base in the shape of a right isosceles triangle with legs that are each 5 feet in length. How long will it take for the water to reach a depth of 4 feet? So just to kind of give us an idea here, I'm going to draw just a little sketch of the pipe. And we know the pipe is 2 inches by 2 inches. And we're using this pipe to fill a pool, and these are obviously not to scale, but it is a triangular prism. Okay, and we know that it is an isosceles, meaning the 2 legs are going to be the same, and this is where our right angle is. So this is 5 feet. And 5 feet. And we want to fill it to a depth of 4 feet. Now the first thing I notice is that I have 2 inches here, but I have 5 feet here. So I probably want to turn these into feet. So we're going to divide these by 12. And that gives us 1/6 of a foot. So this one also equals 1/6 of a foot. Now, they tell us in the problem here, they gave us that it is filling at a speed of 3 feet per second. So what we want to do here is if we want to know the volume of water that's going into the pool, we actually want to assume that this goes for 3 feet. So we'll calculate how much is coming out in 1 second. So that's where I want to start. So let's start with the volume of the rectangular prism. So we know volume is length times width times height for a rectangular prism. And our length and width are both 1/6 of a foot. And our height is going to be 3 feet, or depth rather. When we multiply these, we get 3 over 36, which reduces to 1/12 of a foot, cubic foot rather, in 1 second. Now, it would probably be more helpful for us to find out how much is coming out in 1 minute. So why don't we actually multiply this by 60? And that will give us 5 cubic feet per 1 minute. All right, from there, we know how much it's flowing into the pool now, but we want to know how much volume is in this pool. So let's go ahead and calculate our volume for the pool. Triangular prism. Now a triangular prism, it has a base of a triangle, so we would use 1/2 base times height, and that's the height of the triangle, multiplied by the height or the depth of our pool. So filling in these elements, we know we have 1/2 times 5 times 5, and it's a depth of 4. So if we multiply these two, I'm actually going to multiply the 4 times 1/2 would give us 2, and 5 times 5 is going to give us 25. And so we need to fill 50 cubic feet. Now that I know that we need to fill 50 cubic feet and we're filling at a rate of 5 cubic feet per minute, we just want to divide those two. So 50 cubic feet divided by 5 cubic feet tells us that it is going to take 10 minutes to fill the pool. Okay. So I think that when you're doing this problem, it's very helpful to draw some pictures to help you to understand the shapes and what actually is going on here. And again, notice that unit rate still played a role in this. We wanted to find our unit rate, but instead of doing seconds, it was helpful to do it in minutes.